Good morning, children. In the last class in chemical kinetics, we were studying about the dependence of the rate of reaction on the concentration. We have started that the rate of reaction also depends on the temperature of the reaction. It is general observation that when temperature increases, the rate of reaction also increases. It is observed with the 10 degree of rise of temperature, the rate of reaction gets just doubled. The ratio between the rate constants of the two temperatures differing by the 10 degrees Celsius temperature coefficient is known as the temperature coefficient or the temperature coefficient of the reaction. The relation between the K and T can be given by the Arrhenius equation, which is K is equal to A e to the power minus E over RT, where EA indicates the activation energy and T is the temperature. A is known as the Arrhenius parameter, or it is also known as the pre-exponential factor. It is known as the pre-exponential factor and also called as the frequency factor. Activation energy is the minimum energy which is required to just initiate the reaction. According to Arrhenius, the reactant molecule collides to form the unstable intermediate, which is known as the activated complex. Although it exists for a very short time and it breaks and gets converted into the product. The minimum energy required to form the intermediate is known as the EA, that is the activation energy. If we plot the curve between the energy and the progress of reaction, it curves. The peak of the curve indicates the activated complex, that is the activation energy EA. The difference between the energy of the reactant and the product is indicated by the delta H. If delta H is negative, that is, reaction is termed as the or known as the exothermic reaction, and if delta H is positive, then reaction is the endothermic reaction. Children, now you must come to know that from where delta H is coming. We always observe that in front of the reaction it is always written as the delta H. So any of the reaction can be explained on the basis of the Arrhenius equation. If we go through the mechanism of the reaction, it is observed that the energy is released when the complex decomposes to form the product. So final heat of the reactant depends on the nature of the reactant and product. The plotted curve gives an idea about the mechanism of the reaction. However, there are some limitations of the Arrhenius reaction because all the reactant molecules do not have the same energy. So they all are not coming in equal time towards the activation energy. They don't have same activation energy at the same time. It means to say that. This problem is overcome by the Clark-Maxwell and the Boltzmann, which gives an idea that NE over NT. NE is what? The number of molecules having a particular activation energy, and NT is the number of total molecules. The graph may be plotted between the fraction of molecules over the kinetic energy of the molecules. The area line under this graph gives us the most probable kinetic energy, which again shows a peak. The peak of the curve indicates the most probable kinetic energy. When temperature is raised, the maximum molecules have the maximum kinetic energy, so they have the maximum collisions. At the time when maximum collisions are there, there is the possibility to form the product is maximum. So we can say that when the temperature increases, the activated molecule, the number of activated molecules also increases. If we look into the Boltzmann curve, we can see, we can plot this curve onto temperature, that is T2 and T1, where T2 is greater temperature as compared to the T1. So the fraction of molecules, here we can observe that the fraction of molecules having the maximum kinetic energy get increased. And this area, children, this area shows the number of molecules or the fraction of molecules having the activation energy as the EA. These both lines are not full on overlapping lines. It means they are indicating different things. This peak indicates the kinetic energy and this indicates the activation energy. What information do we get from this curve? The total area under the curve is proportional to the number of molecules present. The total area is same at T1 and T2. The shaded areas represent the number of particles that exceeds the energy of activation, that is EA. From these results, it is easy to explain the dependence of rate of reaction on the temperature. In the next session, we will cover some numerical based on this reaction, on this equation, that is Arrhenius equation, and solve some NCERT problems. Thank you.